Nonneberg, welcome. The first question you might be wondering is why am I qualified to talk about this? And the quick answer is I've been working with Node.js for 3.5 years now, and that's a bit of a long time in the world of Node. But yeah, I've written a lot of programs in it, both for companies that I've co-founded and for a number of companies I've contracted with. So I've seen a number of installations of Node. You see Walmart Labs on that list. You may recognize their name because they've had great success running Node.js on Black Friday. Some good performance numbers, rock solid. They use something called Happy. Anybody heard of Happy.js? Anybody use it? Hold your hand up if you use it. Okay, so I've used it, and I wanted to include some demo code that uses it as well. So if you're interested in the differences between Express and Happy.js, you can take a look at the demo code. I'm only going to be showing Express during this presentation. The other thing that I think gives me some background that's good for this is simply that I've used a number of platforms in the past for money. I've actually worked in all these platforms, and I think gives me some good perspective as to what a developer might be thinking as they approach Node.js. Which brings me to why this topic. I think there's a gap in some of the learning material that you can find out there about Node.js. There's a lot of beginner stuff. There's a lot of feature implementation walkthroughs, but there isn't quite as much about what it takes to get something ready for production, what you might want to do with a Node.js process or a set of applications before putting it in front of customers. And I think Node.js has some particular challenges. In fact, I think it's kind of like your friend says, hey, you like to hike, right? And you're like, yeah, sure, I like to hike. And he says, well, there's this really great hike you should try out, right? Come along. And then it's like this. The hike is not what you expected. In fact, that looks a little dangerous, doesn't it? That's something you don't want to be surprised about. So this talk is about some of those dangerous cliffs and some of the things that you might want to plan for as you're preparing a Node.js process for production. So the first of these is crashes. I think everybody who has written any code has seen a crash. In JavaScript, it's particularly easy to run into, sadly. There's something that kind of unusual in the world of Node.js with regards to crashes, so let's take a look. So if you're following along, you can just use these same commands. So we're running a basic Express app here, and you can see it has a few endpoints that it registers. You can see the first one is a normal error, and that's how you would expect to handle an error propagating up through code that you're calling. But we're more interested in a real crash, and that's what we're doing here. We're creating an integer there, or a number, I should say, because there are no integers in JavaScript, and we're trying to call split, but it's not a string. And so we're going to crash. And so in the browser, you can see that looks like we captured it and we're returning the result back to the user. And so that's what we expect from other programming platforms, right? If you used Ruby on Rails, if you used any one of these other the platforms, you'll be comfortable in that kind of space. What gets interesting is when we start looking at an async crash. So there's a small difference in this handler. It tries to go to the file system, and there's no file called non-existent. And so when it tries to find the length of that returned result, it will crash. And there's very little difference in looking at the code, but sadly the entire process goes down. And that's unusual. I have not seen that before on a well-used programming platform. Ruby on Rails definitely doesn't do this. It just returns the error. So let's start that up again. It goes further. One of the things you can do with Node.js really well is asynchronous programming. So you're going to an API, and when it comes back, you get notified. So this long async task endpoint just sets a timeout, so it's not going anywhere, but it's taking 2 seconds to respond. And when we go to our server, it takes 2 seconds, and there we can see the result. Watch what happens when we load up the async task and the crash at the same time. Sadly, both of them return no response, and the process is no longer running. Now, this is even worse than we thought before, right? The entire server went down, but also things that were in progress are interrupted. And imagine if this was calling a set of APIs, and coordinating a number of changes in that API, and now maybe your data is actually corrupted because things are out of sync, or you're going to your database a couple times. This is definitely not a good thing, and this is the first major dangerous cliff of Node.js. I happen to have written a module that helps with this. The second demo is basically the same thing. You can see it loads up some new stuff before registering all the exact same endpoints with the same code. It pulls in the module and does install a new middleware. But everything else is the same, except for just a little bit of additional code down here. You can come talk to me if you want to know why that has to be. But let's see what this does with that same situation. So we launch the async task and launch the crash. First, we'll notice that we actually get the error back from the crash. What would have crashed the process before actually allows us to see what that error was in the browser, and the process doesn't go down. Similarly, we actually get the response back from the long async task that took 2 seconds and was in process when the crash on the other request happened. So this saves that server from interrupting any requests. That will prevent you from having any extremely difficult to debug data corruption on your server when your server goes down. So what did we benefit from there? That was a kind of a dangerous cliff, something we didn't really expect when we were first learning Node.js. We were able to reduce the impact of that crash, though it was happening in production, to simply shutting down the server when it was ready. That graceful shutdown, as opposed to unceremoniously dropping all connections. Now, before we move on to the next dangerous cliff, I want to mention that this is important from the perspective of deployment too. What do you do with a Node.js process that is out in production and people are using it? What happens when you need to deploy a new service? How do you shut that down? Graceful shutdown is pretty important in this case, and process managers need to be aware of this. Or you should say you should make sure you're aware of what a process manager does to your application. And so I would encourage you, if you feel like it, take a look at those 3 programs in the first folder, the demos, the crashes folder, and when you're making that 2-second long async request while it's still processing something, kill it. So send a signal to it to take the process down and see what happens. It's different for all 3 of them, but deployment is a pretty important thing if you want a good customer experience. The next dangerous cliff is hangs. This was kind of a big deal for me whenever I encountered one before Node.js. It was kind of a tough thing to have happen. Like, you were really doing something wrong in the world of, say, C++ if you did a hang, or if you were in the world of Ruby on Rails and you got a hang. Like, they would take a long time, but they'd end up finishing. Now, in Node.js, however, you can run into this extremely easily. Just forget a callback, and that process is stopped and will not finish. It will not finish at all. And you may think that's hard to do, forgetting to call a callback. If you have any kind of complexity, you have an if-else branching situation, it's pretty easy to fall into. So let's take a look at hangs. You can see there the graceful shutdown. We didn't shut down until that long task was done. So this is another Express app. We've installed a logger. You may be familiar with the Morgan logger in the world of Express. And same kind of thing, we've registered a root endpoint. Just load that up. First, let's start Chrome trying to pull down that hang endpoint. Turns out that's never going to respond, and so Chrome is just going to sit there. But we can also load up our friend, the async task that takes our 2 seconds to load up. What happens if we cancel a request to this? I'll do it again, cancel the request. Let's go look at our log. So note our first request to root, it's 200. We start that long task and it finishes, and we get a 304 because we've cached the response. It's always that success. And then this next time, we start the process, it's still working, and we get an entry with no timing on it. And this is interesting to note because all we did was cancel that request and we have no timing in the log. Now, sad to say, this is actually what shows up in your log when a hang happens as well. And so if you're using a standard logger in your node process, you likely won't be able to tell the difference between canceled requests and requests that you never sent a response to. So while we wait for Chrome to finally give up and give us a log entry there, let's pull up a different approach to figuring out if there are crashes happening or hangs happening. This is an Nginx error log, and if you use Nginx as a reverse proxy in front of your node process or node processes like I do, I found good success with that. It will tell you when your upstream server crash or I keep wanting to say that hangs, and so your timeout, the upstream timing out, will tell you that you never responded in time. And the default timeout for Nginx is still 60 seconds, so you probably want to take that number down a little bit because you don't want your users waiting around that long before, say, you switch to another machine if you're load balanced. That's still a long time to wait before you switch to a second machine, which may respond faster. Now, this is using a technique of just timing out after a predefined amount of time. You can actually do this in your node code as well. And that looks like this. We have a connect timeout middleware that we're installing, and we're asking that connect middleware to basically respond for us if the request takes longer than 1 second to send the response back to the user. You can tell it to respond or not, but in this case we're responding. The thing that I don't like about this approach, the reason why I like Nginx telling me about these situations instead of middleware, is this line right here. In order to properly use the timeout middleware in Express, you, before sending your response back to the user, say you have a 2-second long async like we just did. We can actually start this up and I can show you. Oh, there you go. Chrome has finally given up once, and I think it may even be continuing to try. So that's a reason why you shouldn't ever have hangs visible to your users, because Chrome will try multiple times. And that's 4 or 5 minutes actually that it'll take before it's finally done. Let's see. So we want D. So the same code that we saw before here, the 2 seconds, it responded in 1 second. The timeout fired, and we got the response timeout. Same thing actually goes for the hang. But again, because that middleware replied for us, we have to check that Boolean on request before sending the response back ourselves. And that's just, it's a little bit too much code from my perspective if you can get the same behavior from your reverse proxy or your load balancer, whatever you're using in front of your node process. So we were able to dig into hangs a little bit, but the thing that we can do with these that I think improves our production situation for this kind of issue is simply detecting it. In theory, you don't have this happen in your code very often. In theory, if you get to 100% code coverage, you shouldn't really have hangs. I've actually found that with 100% code coverage, I don't really get hangs, but you may not get to that level. You may not be testing comprehensively. Therefore, if you have hangs happening in production, you definitely want to know about them. And again, standard logging will not tell you if you have hangs or not. So I would recommend something like either a timeout middleware or a reverse proxy that can tell you if you've timed out. Before we move on, a note about logging. Say, for example, you are writing a Node app that is not a server. It's not working with clients directly. It's not serving requests. Hangs are particularly problematic in this case. Say, for example, you have something that collects stats every X seconds. If that thing goes into a hang, you're out of luck, and you'll never know because you don't have something like Nginx in place. This is where I would recommend not only error capturing. A lot of people, it's easy to put in like, well, if it crashes, I'll know, right? Because I have a monitoring system for that. But the other side is positive metrics. So if this is collecting stats, how about some sort of I collected stats successfully message so you can check up on your process. So non-server apps are a particular focus area for hangs. I think they require a little bit of extra thinking and an additional system. Now the next is event loop unavailability. And if you're new to Node, this one is bewildering, I have to admit, the way the event loop works and the way that you can mistreat it. Now when I say unavailability, I mean a not healthy event loop. And what is a healthy event loop? Well, it's going through tasks, small tasks, very frequently. And so there's low latency through the event loop. Now, how can we disrespect that? How can we make that unavailable? Well, let's take a look. There are a couple ways. So let's pull up. Now what you're seeing here are 3 different functions. The first is an interval set up to run every 100 milliseconds. The next is a getFile method that simply goes to the file system, and when it gets its result, it tells you how long it took to get its result. And then a do sync work, which is it's a sad bit of code. I didn't really like having to write it, but let me show it to you. Do sync work spins for 1 whole second. Don't do this. Don't do this. It's bad. All right. So what we see here is a number of interval check-ins, and between them, it's at least 100 milliseconds. We see a getFile call, and this is a healthy event loop. We're getting a response in 1 millisecond, and that's what you generally expect in the world of Node. These things happen quickly. Now, here we start another getFile, and then immediately do a whole second of synchronous work. Now note what happens. Not only do we skip interval calls because we had blocked the event loop during that time, we also cause that getFile to take 1 whole second because it was launched before that synchronous work happened, and the callback had to wait until you were done monopolizing the event loop, and so it only gets called back after the synchronous work is done. So that's one way to make the event loop unavailable. You can do a long task on the event loop. If you're going to do long tasks like this, I would recommend taking it off the event loop, like some sort of shell out to some task or some sort of a kind of work queue situation. The next way to make the event loop unavailable is to overload it. And instead of one big task blocking the event loop, we're putting too much onto the event loop. So what you're seeing here is 3 metrics. We're checking in with an interval again pretty frequently. The lag is how long it takes to get through the event loop. The concurrent tells you how many things are going at once, and the completed is how much work we got done between that and the previous check-in. So that lag you're seeing is we're doing a lot of work on this event loop, and that lag tells you how long that get file would take in this context. So you saw in the previous demo, the get file took 1 millisecond to respond. In this case, whatever lag you see there, that's how long the get file would take. Now, that's not an overloaded event loop. Let's show you what an overloaded event loop looks like. So this little application, I would recommend you play with it. It's kind of interesting to play with. There's the launch delay, how frequently we launch tasks, how many tasks we launch whenever that fires, how much synchronous time we delay before one of those tasks fires, and then how much synchronous work, similar to that previous demo where we did 1 whole second of synchronous work, and these are all in milliseconds. So if we double the speed at which requests are coming in, instead of 100 requests a second, we're going to go to 200 requests a second. Now imagine this is a server, and we just doubled the incoming traffic. It's pretty dramatic. That is not a good trend. In fact, I don't want to run this too much longer because my fan's going to turn on, I'm going to overheat. There we go. Okay, that's enough. You do not want your event loop to look like that. Again, the same thing applies. That 1 millisecond get file will take 1,000 milliseconds near the end there, and it's just slowing down. We're taking on more work, and we can't keep up. This is definitely one way to make the event loop unavailable. Now that we know what this looks like, what are some techniques for dealing with it? Well, the first is the same tool we're using to detect what the lag through the event loop is. We can consult it if we think, or if it thinks that we shouldn't take on any new work because the event loop is not looking so good. So we can turn that on, true, and watch what happens now. We're taking on the same number of incoming requests, but now we're rejecting requests if we're not feeling like the Node.js process is doing so well. So I wouldn't call this a healthy process, but note that it's not a geometric increase, and we're kind of limping along. We are rejecting requests. I would definitely not call this a healthy process, but it does allow you to at least service a few requests from your clients. And note that this doesn't completely fall over. It's actually able to continue processing. So what does that look like in an Express app? Well, here we're using a middleware that uses that same toBusy technique and returns 503s, service unavailable, if it looks like the event loop is a little bit overloaded. There's another technique for dealing with event loop unavailability, and it's more related to that one really long, too much work at once type situation. And that is limits to the amount of data that you take in at any given time. Say you have an API that you've starting to write in Node.js, and you're taking data posted on post endpoint, and somebody decides to send you 3 megabytes at once. That's not going to work too well, especially if you process that data at all. And so you can limit it. You can say, I only want 1 kilobyte at a time. We do not need any more than that, because our API just doesn't need it. And if users start running into it, then you can change the limit. This gives you an example of how you might operate if you have that kind of situation in place. You can assume you have all the data at once, and so you can just get the length of the values, right? Very easy. Now, this doesn't necessarily work if you're dealing with bigger and bigger data. And so Node.js is useful not just for little bits of the tiny little API requests. It's also useful for streaming big things or proxying requests, things like that. And that's where streams come in. So we're doing the same thing. We have our logger. This time, instead of the upload data just having rec.body that it can access directly because it's all been parsed out, we're using a stream now. I will admit that streams are a little tricky to deal with. And I'll also say they are frequently overkill. I would recommend that you only implement this when you know you're going to need it. If you're dealing with more than, say, 2K per upload, you will probably, if you're dealing with more than 2K, you probably want to use streams. And what this does is it chunks that big amount of work into small bits. And in this case, we're doing the same thing we did with that other endpoint. It's a little bit more work and it's harder to read, certainly. But it does allow us to deal with as big of a JSON blob as our user could give us. We simply go chunk at a time. And this JSON stream parser will give us an event for the parts of the JSON that we care about, and then we return the result back. So that previous upload data endpoint I showed you and this upload data that's based on streams, they are functionally equivalent. It's just that one can handle far bigger chunks of data. This is a quick example of how to send a stream back. The key is to set your headers and such, like the type. If you're sending a JSON blob, you should probably tell your client that it's JSON, but then you can just send that pipe right on down. You're connecting that pipe from the file system and connecting it directly to the response to the user. So what do we see there? We saw prevention. I mean, if you're using streams, you're avoiding any difficulties with too big of data slowing you down. If you're looping over 1 million records in some JSON blob, that'll take a while. And to some degree, we're preventing really bad things from happening when you watch the event loop and you use that toBusy module to reject new work. Now, I wouldn't say that's a perfect solution. It's a stopgap. You should probably add new nodes. You should probably change your architecture a little bit if you're running into that frequently. But again, we're also detecting. When you send those 503s back, it's certainly better than some machine in a data center somewhere running out of memory and killing your Node.js process unceremoniously, which happens. So you've detected it. You're seeing those 503s in your logs, and you're going to address it. The next dangerous cliff is something we run into all the time. How many people have called an async method in Node.js? Yeah, I hope you have, okay? And how many people have seen an error come back from that? Yeah, okay. So let's take a look at what we can do there. So you're probably familiar with this kind of approach. We're using async.series in 5 steps. It's something that's pretty easy to do. Now, what do those 5 steps do? They each call some sort of remote service. Say, for example, you're going to the database or you're going to some remote API. Here in our call remote service, just so I could make this hard to debug, this is a probability thing. We return a new error, and let's see what happens when we run into an error. Ooh, let's actually try that again. There we go. That's what happens when the error did not fire, that first one. Okay, so if the error fires, we're using probabilities here, we actually only get 2 elements in that call stack. And the reason is because that's coming back from an asynchronous callback, and the system says, oh, a timer needs to fire. I fire the timer, and I call this callback. And that comes up into the call remote service, which creates that error there, and then that's passed up via if error return CB error. Now, I don't know about you, but I find that a little bit difficult to figure out what's going on. I would like to know what step that ended on. I would like to know what steps were run and what steps weren't. It's not too much to ask, right? Again, I've written another module here. Let's take a look at what that module can do for us. So this is the concept is breadcrumbs, and in that same situation, now we see 4 elements or 4 items in the call stack. There's a little bit more there we'll talk about later, but let's actually trace what happened now. So line 13. So line 13 is where that error is thrown. Line 32, where is it? Oh, it looks like step 2 is actually where it failed. And step 2 is the one that didn't get completed fully. Nothing after step 2 is run, so now we know. I just want to point out how this works. Breadcrumbs.add takes the error and the callback, and then will add something to the stack, so you know how that error was propagated back up through your code. Additionally, I like the fact that it takes the callback because now I don't have to worry about some sort of typo like C error, which would crash immediately on running it, and nobody likes the dual crash where there was a problem in the application and then my error handling code crashed. Nobody wants that, so we just return there. If we go back to our call stack, there's one more line that we can see, and that's 82. And that actually takes us to our multi-step, which has the same add. And this is where some additional data is actually added to the error to assist with debugging in our logs. And so that's what we saw here with the user ID and the command. The breadcrumbs allows you to add that debugging information you will need if this happens in production directly to the error, which will allow you to better handle that situation. Now, say you use promises. I like callbacks, but maybe you use promises. Let's take a look at what you get when you do promises. So maybe you use when or Q. These are drop-in interchangeable. Well, sadly, the call stack is the same. We just get the 2. We don't actually know how the error flowed from there or how we got there. Happily, there is one promises library that I can recommend wholeheartedly, and that is Bluebird. So let's take a look at what that does for us. Now, this is a little bit hard to read on the small screen, but first we have the same call stack that we got before. It's the two items, one from the system and one from where the error is thrown. But we actually get because we're using a feature of Bluebird called long stack traces, we get the previous call stack, which is the one tracking down into the async. You could think of this first call stack as the up back out of async, but this other call stack is the down initially. And this tells us that it was step 3 that crashed, or that that was the last one run before the error happened. And so Bluebird is an interesting option for promises. So with async errors, which we run into all the time, and they're not even necessarily programmer issues. These are, services down, or, the database is not configured properly, et cetera, et cetera. We get debugging information. I think it's extremely important when you have something in production to have enough data collected to make it easier, or somewhat reasonable at least, to figure out what's going on and then solve that problem. Whew, that was quite a hike, huh? Quite a hike. Before we shut down, I want to talk about these kind of higher level concepts. So as we're thinking about issues that could crop up in production code, I think it's useful to think in terms of these categories. First, prevention. I hope you're testing. We're all testing, right? Testing. That's the first line of defense. However, you cannot ensure with 100% certainty that you're not going to crash in production. And so we can do some work to make sure that the impact to a production service is minimized. And then if something is happening in production, we want to know that it's happening. I can't even stand the thought of my users getting hangs and maybe not telling me about them and just not paying me money anymore or something like that. That's not a good result. I'd rather know before they even realize what's going on. And then debuggability, so that when something happens in production, making sure you have enough information to deal with it. And hopefully, as we talked about this, you've gained a little bit better understanding of Node.js. But before we go on, I have one bonus for you. If Node is good at anything, it is massive parallelization and very efficient use of local resources. Now, if you're calling a service that doesn't quite have some of those characteristics, you can bring a service absolutely to its knees. We've heard of, I was on a contract recently where the load balancer was essentially crashing, and we were getting the socket hangups that you would get if a Node service crashed. Be respectful. Know what you're doing to that remote service. The defaults in Node.js now are unlimited sockets, sadly, which means that if you don't pay attention, you can definitely do bad things on the internet. And so I would recommend that you take a look at the section 5 in my demo code. There are 2 services, or 2 files in there. One is the client, one is the server. And you can mess around with both of them to see how they interact with each other. There are a couple techniques talked about, or included in there for dealing with the client basically taking down the server. So like when an error happens, scaling back, limiting the number of sockets, etc. So with that, thank you very much for listening. Hopefully you found some good value.